Hey class, it's Mrs. Sorrells. We are going to go through this as quick as we can. You're going to do a couple things. We're going to look at what the paper you saw in class today. You're going to either finish the paper with me, or you are going to double check your answers to make sure what you have is correct. Then you're going to see a short clip of Engelman, and then you'll hear me finish up the video. So let's start with the acute angle. An acute angle, if you wanted to define it, it would be an angle measuring more than 0 but less than 90 degrees. Okay, so it's got a range there. Some little facts and characteristics that could help you is you could call it the word acute. You could split into 2 syllables. Acute, so you can call it a cute little angle. Okay, so it's the little one. It can look like the letter V. I'm over here over here. No vertices. Oops, that should not be on there. Cross that out. Wrong. That's the wrong characteristic for something. Okay, but it is an angle that's between 1 degree and 89 degrees. So the second it becomes 90 degrees, it's no longer an acute angle. It becomes a different name. And if it goes to 0 degrees, it's also a different name. Okay, so it has to be between 1 and 89. Here are some pictures of what it could look like, and here are some non-examples. We have a straight line, and this one is obtuse down here. Now, remember that you can rotate the paper. So, I mean, most of the time you see it like this, or you visualize it like this one right here I'm highlighting. But remember that it could be backwards, it could be rotated, it could be all different directions. But you still have to recognize it's less than 90. Here is what I showed a couple of my classes. Okay, if this was the base and I wanted to create a 90-degree angle, I'm going to draw this invisible line right here. That blue angle would be a right angle. And so if I'm going from this corner to the 90-degree angle, I'm trying to see, am I past the 90-degree angle? Am I before the 90-degree angle? Where am I? Well, when I'm going this direction towards the 90-degree angle, the green line, the other part of the angle, comes before the 90 degrees, which means it's less than 90. So estimating can be a good strategy or tool, as well as identifying the angle. Okay, and that'll help you when we get into actually measuring angles. All right, let's go to the next one. Just a second. Come on. Alright, next one, obtuse. So it's an angle that measures more than 90 but less than 180. Okay, some facts or characteristics. It's in between a right angle and a straight line. The word obtuse can mean large, huge, big, enormous. So that can help you remember. You've got the acute angle, which is an acute little angle, and then you've got the obtuse, which is a big angle. Okay, now this one, the angle is between 91 degrees and 179 degrees. As soon as it hits 180 degrees, it becomes something else, and if it drops from 91 to 90, it becomes a right angle. Okay, here are some examples. Again, remember that it can be rotated, turned, etc. And here are some non-examples. And I'm going to move on. If you do not have these pictures down, you need to stop the video and copy them down. If you already have them, I'm not going to waste your time. Alright, next one. Right angle. Okay, so it's an angle that measures exactly 90 degrees. Exactly. Okay, so here's a cool fact that I found when I was Googling it this morning. Good old Google. It's one of the most used angles. It's everywhere. If you just stop this video and you look around, you're going to see right angles in your room, your car, wherever you're at, and you'll see them everywhere. Okay? The other thing is it's a precise measurement. That means it's an exact number. It cannot be anything other than 90 degrees. No ifs, no ands, no buts. Okay? It has to stay that way. It's non-negotiable. And then here's another characteristic that y'all know, that y'all can recognize the right angle, and that's it shows the corner and the box, or the box and the corner, or the vertex of the right angle. So let's look at these examples. You see the square there, recognizing and identifying, okay, that's a right angle. Okay, you see it in all different directions. And I've also put letters on it. So this right angle right here would be angle A, B, C. So you need to get used to seeing the angles named with letters. Okay, this would be right angle DEF or FED. Okay, and then you could make up your own letters for this one. Okay, some non-examples. Here's an obtuse and here is an acute. Whoops, I forgot this. Here's another important detail. As we're going, teaching as we're going. This little semicircles in here, they have to be drawn there. Okay, otherwise, so the blue one is the one we want. If you didn't do that, I might think that you're telling me to measure this angle on the outside in the yellow. And that's not what I want. I want from this point to this point on the inside, so I needed to draw that circle. Okay? Alright, moving along. Last one. Straight angle. Okay, this one might be new. Now, I know you know what a straight angle or a straight line is. Okay, so this is either a straight angle or a line. Alright, now, this does not measure 0 degrees. It's 180. It's exactly 180. Okay, and if you look at a protractor, we can show it to you in class. You'll see on the protractor, draw a little picture over here of a protractor. This would have 0 over here, and then it goes from 180. So your straight line starts at 0 and goes all the way to 180, leaving the straight line with 180 degrees. Facts or characteristics, simple. It's a straight line, and it's also two 90-degree angles. And here's where that other one I crossed out earlier needs to be added. There are no vertices. Shout out to Michael Nguyen here. He pointed this out in class. I didn't even come up with this one, and I thought this was really great. There's no vertices. It's just a line. No two points meet together. Okay? Now let me explain the two 90-degree angles combined. If you have this straight line down here in your examples, if I draw an invisible line smack in the middle, whoops, that was supposed to be yellow, that creates a 90-degree angle here and a 90-degree angle here, which 90 plus 90 equal, woohoo, 180. Okay, so that's where you get that's why it's 180 and not 0 degrees. And then make sure you have some non-examples down. Okay, again, make sure that these are completed. These will be put in your notes tomorrow, and then you need to, on a separate sheet of paper, after.
Oh, hello. I'm just popping out for a pizza and wondered if you lot would like to come along too.
Too right, Elwood.
Oh dear, I almost forgot. You lot aren't allowed out.
I'd love to go out.
No yearning without learning. Until you've learnt your maths. You lot, stay here. And you can stay out of here.
Whoa, hello. Oof. Do you know who I am today? I'm Angleman, because I've got my angle bangle. If ever I'm called upon to estimate an angle fast, I'm always ready with my angle bangle with its built-in protractor. All I have to do is line it up and make sure that my angle bangle is centred where the lines meet. There we are. And that's 50 degrees. Yes, a very good estimate. Now, there will be no one estimating angles faster than me, Angleman, and my angle bangle. Woohoo! Angleman, Angleman, measuring angles faster than any human can. Angleman, Angleman. He's such a quick reactor, watch him whip out his protractor, all part of his cunning angle-bangle plan. He can find out just how many degrees eyes are in the angle of an elephant's knees, and antler angles on a moose might be acute, might be obtuse. Angle man, measuring angles faster than any human can. Angle man, he's such a quick reactor. Watch him whip out his protractor, all part of his cunning angle bangle. Angle man.
Alright, so I hope you enjoyed that nice little video clip there. Fortunately, I can't talk with that accent, so sorry. But we'll make it as fast as we can. If I can't make it interesting, we'll make it quick. Okay. This is how you read a protractor, and I need to explain this. Engelmann did a pretty good job, except his protractor looked a little bit different. If you look at our protractor, it has two numbers in each spot. It's got 170 and 10. It's got 160 and 20. It's got 150 and 30. So here we are, and we're stuck without knowing which number to pick. This is why you have to know how to identify the angles. And identifying is saying, okay, is it acute, is it obtuse, or is it right, or is it a straight line? And that will help you pick which number. Okay, so if you are reading the protractor and your angle is obtuse, you're going to use the larger number on the protractor. And I'll show you what I mean in a second for you visual people. And if your angle is acute, you're going to use the smaller number. Now if it's a right angle, it's going to lie right on the 90 degrees. Okay, so that'll help us. So let's look. The first off, you need to know that this sign right here means angle. Okay, so this reads angle F-A-B. So I'm literally just, it's fab. We're fab today. Okay, so we're just going to literally go from F to A to B, and that's the angle I'm reading. Okay, so F to A to B. Now if I look at this angle, my first thing I need to do is identify it. Is it obtuse, is it acute, or is it right? Well, it's obtuse. And the other thing I need to check is Engelmann talked about one of the rays, one of the lines of the angle need to lie on that straight line down at the bottom, the 0 degree or the 180 degree line. Okay, so we're good there because this line AB is on that. Okay, so now I know, okay, I've got that lined up. It's an obtuse angle, so I'm going to use the larger number, and then I'm going to read it. So if I go from here all the way over here, come on, pen, I've got two options. It lies right here, 40 or 140. Now here's where you choose. If it was 40 degrees, it would be an acute angle. And this isn't an acute, it's obtuse. So that's why we choose the 140, and make sure you put the degree sign. Okay? Alright, on the second one, we're doing angle D to A to B. Okay, first step is, well, that was bad. First step is one of the rays on the 180 degree straight line. And it is. Okay, so we're good there. Second thing is we need to find out, so if this line goes from here to here, I got to find out where this line intersects on the protractor. And it's either one of these numbers. It's 80 or 100. Okay, now we said, well, we didn't say, what is this? Is this acute or obtuse? Well, 90 degrees would be right here. Okay, and it's more than that, so it's the obtuse one, meaning it is the 100 degrees angle. Okay, make sure you put the degree sign. Alright, let's look at another one. Angle BAC. So I'm going from here to A, sorry for the overlapping, to C. Again, let's check. Is one of our rays or one of our lines on the angle on the straight line? And it is, so that's set. And now I have to see, is this acute or obtuse? Well, previously I drew the 90 degrees right here, And so if I'm going from B to 90 degrees, it's less than, it doesn't quite get to that 90 degrees, it's less than 90. So it's acute, so I'm going to use the smaller number on the protractor. And so here it's not exact, but we're going to get as close as we can. Okay, it says 60 or 120, okay, and it's acute, so I know it's 60. Now I have to pay attention, y'all. Look at the numbers, the 10, 20, 30, 40, 50, so it's almost 60, so it's about, I would say, 58 degrees. It is not 62 degrees. 62 would be over here, okay, and the reason why is you have to pay attention to the direction of the numbers. Okay, the smaller numbers go from right to left, and then the other way is left to right, so pay attention to that. Okay, the fourth one, we're going to get a little bit harder, is angle FAD. Alright, let's see. Angle FAD. Okay. First thing is one of the rays on the 0 degree line? And it's not. So we have a problem. How am I going to find out from here to here, all this right in between, and find out how many degrees that is? Okay, well here's what you do. You have to find the difference between here and here. Okay, so you can do two things. You can, first off, it's acute. Okay, so let's use the smaller numbers. So it starts at 40 and goes to 80. I have a couple different strategies I can use here. I can literally just count using the number. So like 40 to 50 is 10, 50 to 60 is 20, 60 to 70 is 30, 70 to 80 is 40. I could do that. Or I could say, okay, I've got 80 degrees here, 40 degrees here. Come with me over here. So 80 degrees and 40 degrees, and find the difference. What do you get? 40 degrees. Okay, so same answer, a couple different ways. Okay, and then let's look at another one like that. Angle DAC. DAC. Oh my goodness, my lines are not straight. Okay. Oh man, I've colored over it so much I don't know what that says. Okay, that's 70, that's 90, that means this is 80. Okay, again, it's an acute angle. So I'm starting at 80 and it finishes a little bit past 120. Okay, so there's 10, 20, 30, 40, 42 or 43. Okay. Or I could go and say, okay, this one's 122 or 123. Again, we're getting as close as we can. And this one is 80. And I'm using the smaller numbers because it's acute. And I could subtract here and get my 43 degrees. Okay, now we will have some protractors in class that we might let you use, but really on the STAR test you're not going to get a protractor. You're going to have to be able to read it like this, so we've got to get used to reading it like this and practicing. Okay, so tomorrow when you come into class, make sure you have your video notes and your Frayer models and your Google Doc done. Okay, and then we will practice doing this more in class tomorrow. Okay, thank you. Have a good night.